welcome all to another session of Concept at Fingertips. This is Vidya, Physics faculty. Today we will be learning the topic Electromagnetic Induction using two coils. So in the previous classes, we had seen that electromagnetic induction was happening when we move a conductor in a magnetic field, or when we are bringing a coil towards a magnet or a magnet towards a coil. In other words, if there is a relative motion between a coil and a magnet, there was an induced current developed in the coil. So this phenomena is known as electromagnetic induction. In today's chapter, in today's session, what we are going to see is, like if we have two coils instead of a magnet, if we have another coil which can produce a magnetic field around it. For example, here coil 1. So as we have already seen in another previous session that if there is a coil and if that coil is connected to a cell, and when current is passing through the coil, then a magnetic field is developed inside and outside of the coil. So this magnetic field is very similar to that of a bar magnet. And we have seen the direction of the magnetic field also. So this magnetic field will be very much similar to that of a bar magnet, just like a bar magnet. So inside the coil, the field will be uniform, and outside the coil, it will be like that. So one end of the coil will become north, and the other end of the coil is going to behave like south pole, thus creating an electromagnet. In the same way, for this activity that we are going to see, here coil 1 is connected to a battery. The coil 1 is connected to a battery, via key K. So when the key is closed, when the key is plugged in, what happens is there will be a current that will be flowing through the coil 1, and the current increases from 0 amperes. So when K is plugged in, the current through the coil coil 1 increases from 0 ampere to the maximum value I. In a very small interval of time. So during that small interval of time, what happens in this coil is that the flux or magnetic field of this coil will change from no field to a particular value of field. So particular amount of field. So that field will be actually coming out like that, and that field will be actually linking with the second coil as shown in the figure. That field which is produced in the coil 1 will be linking with the coil 2. And as far as coil 2 is concerned, the field that is being linked with coil 2 is changing from a small value to a large amount of field, or the flux lines are increasing from 0 to a maximum value. So because of that change in flux, in coil 2, an induced EMF is produced in coil 2 circuit. Which in turn will produce induced current. Induced current. So what we can observe is that galvanometer deflects to one direction. And it momentarily comes back to 0. So galvanometer deflects to one direction and momentarily comes back to 0. So the deflection in the galvanometer is for a very short interval of time, and it deflects to one direction and then comes back to 0. So this is the first part of the experiment. And in the second part of the experiment, what we are going to do is we are going to remove the key. So this time we are removing the key. So when K is removed, when the plug is removed, what we can see is again the current which was I will reduce to 0 in a small interval of time. So this happens in coil 1. In coil 1, the current reduces from a maximum value to 0, and that too in a very small interval of time. Now, because there is this change in current in the coil 1, there will be a change in magnetic field around coil 1, which will be linked with the coil 2. Again, so the same magnetic field is linked with coil 2. So in turn, the magnetic field linked with coil 2 also changes. So what happens if there is a magnetic field that is changing around a conductor or a coil? It will induce an EMF. So that is known as induced EMF, and we know the phenomena, it's known as electromagnetic induction. So here also induced EMF will be produced, and a current will flow in the coil 2 circuit. So this time the direction of the current will be opposite to that of the previous, because the flux is decreasing from a maximum value to a small number of flux lines. So in that case, or in other ways, the current is decreasing from a maximum value I to 0. So in this case, the EMF induced will be in the opposite direction and the current will be in the opposite direction. So the deflection in the galvanometer, deflection will be in the opposite direction. Meaning In the first experiment, if the galvanometer deflected towards the right, in the second one, it will deflect towards the left. And again, this change in current, which is like maximum I to 0, is also a momentarily change. That will be therefore only a very short interval of time. And by that time, the current will be completely becoming 0. And the magnetic flux and everything will be stopped, right? So because of that, the deflection will be in the opposite direction, but still the deflection will happen only for a very short interval of time. Not even interval, a very short moment. It will be a momentarily change. Direction for a short moment of time. So in this setup, the first coil or the coil 1 in which we are actually producing the magnetic field by using an external battery. So that is known as the primary. So coil 1 is known as the primary coil, and the second coil in which we are linking the first one's magnetic field is known as the secondary coil. Secondary coil. So here, the change in current in the primary resulted in inducing a current in the secondary. This phenomenon, as we already know, is known as electromagnetic induction. And when we are using primary and secondary coil like this, in this way, we call it as mutual induction. I hope the topic is clear to you. Meet you in another session with a new topic. Thank you.